So yes, the next is deletion from a given position of the double linked list. So for deleting, first I have to check whether the list is empty or not. If the list is empty, there is no question of, if the list is empty, then head is equal to null. That means there is no question of deleting any element. And if the position is equal to 1, that means I need to delete the first element. So I will directly call the function here delete at head and I will return. So now if the position is not equal to 1, here is this is equal to 3 now. So that means I need to delete this third element now. To delete this third element, I need to first traverse all the elements from the beginning up till this point. So right, so traversing, these steps are basically for traversing, right? So these steps are basically for traversing. Again, the same steps which we did in the previous lectures. I will take a temporary variable here, temporary pointer variable here, take a count variable here, initialize it to 0. In this algorithm, I have written the PPT. By mistake, I have written here is 1, but otherwise, please make the small modifications and take it to be equal to 0, right? So count is equal to 0, that is initialized. Temp is equal to the memory address of the first element. So both head and temp are now pointing to the first node. So now I have to traverse it. First I will check for the terminating condition. 0 is less than position minus 1. Position minus 1 is 3 minus 1 is 2. So that yes, this terminating condition is satisfied. So that means I am in the loop now. I will be in the loop. The value of temp will have to be updated. So this has to be equal to temp ka next. So temp ka next is 200. So it will point to the second element now. The value is equal to 200 now. Value of count has also been updated. Now this is equal to 1. Again I will check for the terminating condition. 1 is less than 3 minus 1 is 2. Again the terminating condition is satisfied, so I am still in the loop. So again I will update the value of temp here. The updated value of temp should have temp ka next. I will get the memory address of the next node from this temp ka next. So again the value of temp will be updated and it will be equal to 300 now. The value of count will be updated. It will be 2 now. Again I will check for the terminating condition. Present value of count is 2. 2 should be less than position minus 1. But now this condition is not satisfied. Since this condition is not satisfied, that means I have come to the required node here, right? So I have come to this node here, and I will take that means I will be out of the loop. That means I will take another pointer variable here, current, and this current value should have the memory address of the temp here. So memory address is temp here, so this is equal to 300 here. So this is equal to 300 here. Now basically I have to delete certain links here. So I have to delete these links. Please see this thing. This link has to be deleted. This link has to be deleted. This link has to be deleted. This link has to be. So these 4 links need to be deleted now. And to delete these 4 nodes, these 2 pointers, they need to be updated, right? So what is this pointer called? This pointer is current. That means this node. Current, that means 300 का previous is this previous का next is this, right? So current का current का previous का next. I am again repeating, current का previous का next. So this pointer is there, this needs to be updated, and this pointer also needs to be updated. So this pointer is current का next का previous, right? current का next का previous, right? So current का next का previous. So these two nodes need to be updated, right? So this node, if I talk about this node, it should have the memory address of this node here. So how, that is 400 here. So how will I get the 400 value here? Current का next. So I will write here current का next. This node has to have the memory address of this. Instead of 300 here, it should have the memory address 400. Only then this link will be created, right? So to create the linked list, it should have the value 400 here, and 400 is stored here. And what is this value? This is current ka next. So I have written here current ka next, right? So next is I need to after this statement, this link will be created and this link will be deleted, this link will be deleted, right? So next step is I have to update this node, this link, and instead of this link I should have the memory address of this. Only then this link will be created, right? So instead of 300 here, it should have the memory address that is 200, right? So to have 200, how will I get it from 200? 200 is written here, 200 is written here, right? So what is this value? This is current ka previous. So current ka previous, right? So current ka previous. So once this statement is executed, this link will be deleted, this link will be deleted, and this link will be created, right? So I will have the value here 200 and I will have the value here 400, right? So both these steps have been done. So once these 4 steps are done, I will free this node. So this is this node is, the pointer of this node is at current. So I will write here free current. So this memory will be released now, and deletion has been done. So that was all regarding the deletion.